Hello, and welcome to our virtual seminar, Propel Your Quant Methods Downstream with Lunatic's QC Tools. My name is Rifar Jingils. I'm your Senior Director of Field Application Science here at Unchained Labs, and I'm really excited to introduce Dennis, our Product Manager for the Lunatic and Stellar product line. Today's webinar is an exploration of the performance and compliance tools required and available today on Lunatic to be able to move it from your early stage development all the way through your downstream processes. And so without further ado, I'll pass it on to Nels. But before we do so, I'd like to encourage you to join in the Q&A session at the end of the presentation by clicking at the bottom of your screen on the Q&A button, as opposed to the chat, and submitting your questions. And we'll answer as many of them as we can within the time allotted to us. So without further ado, Nels, the floor is yours. Thank you.
Thank you, Rifar, for the intro. So let's get started. Propel your quant methods downstream with Lunatic's QC tools. Rowing a boat has its pros and cons. It takes quite some hands-on time, but at the end of the day, you'll get where you need to be. As long as you only need to go small distances and you have the time, you'll probably enjoy the view along the way. Validating protein and nucleic acid quantification with classic methods feels very similar. As long as you have the time, you'll get where you need to be. But in the end, save rowing for the weekends. During the week, you need to get the job done as fast as you can. Current systems that give you the great results needed to work downstream are slow, one at a time, and require larger sample volumes, while other micro-volume systems are fast, but they don't pass the high bar of working downstream. Now, let me show you today how Lunatic combines micro-volume, high-throughput UV-Vis quantification with amazing accuracy and precision, so you finally can have it all. Our Lunatic is a full spectrum UV-Vis spectrometer, which requires only 2 microliter per sample and no dilution steps or standard curves. Lunatic can measure up to 96 samples at a time in just 10 minutes. Our plates have a standard SBS footprint, so they're fully compatible with multi-channel pipetters and liquid handling robots. Lunatic is the only system out there that can measure nucleic acids and proteins at high throughput and high concentration. It uses a microfluidic circuit with 2 fixed pathlengths to cover a wide dynamic range of 0.03 to 275 OD. And that translates into 0.02 until 200 mg per mil IgG, or 1.5 until 13,750 nanograms per microliter double-stranded DNA. The unique microfluidic circuits molded into our Lunatic plates ensure that there's no cross-contamination or evaporation. Once the sample is loaded, it's pulled into the reservoir area by capillary action. When the sample hits a hydrophobic point, it will stop. At this step, the sample can sit for up to 2 hours before reading, with no evaporation. After the plate is loaded into the instrument, the empty microcuvettes are read first. That will remove any absorbance contribution from the plastic. And then a pump applies a small vacuum, which moves the sample into the microcuvettes for the actual reading. Here we can see exactly what sample loading looks like, with the help of some fluorescein and a black light. In 2 wells, we've already added 2 microliter of fluorescein. As you can see, to load another sample, you simply add in 2 microliters into that input well, and the sample wicks into the plate. On the left, you can see those loaded samples, and on the right, you can see the samples after being measured with Lunatic. The 2 diamond shapes are the cuvettes for 1 sample. What this also shows is, after pumping, all the sample remains in our consumable, so there's no contact between the sample and the actual pumping system. No contamination possible. Now, before I show you the data on real samples in our actual plates, let me show you how rock solid our system and our consumable is. Compliance with certified standards for analytical tests is a must-have for biologics manufacturing and quality assurance and quality control. The United States Pharmacopeia and the European Pharmacopeia lay out test protocols and acceptance criteria to ensure that UV-Vis spectrometers are suitable analytical tools. Test protocols for UV-Vis spectrometers cover absorbance accuracy and precision, photometric linearity, wavelength accuracy, resolution, and stray light. Now, let's walk through results on Lunatic with the required standards to pass all these pharmacopoeia protocols. To pass USP and the European Pharmacopeia, requirements for absorbance, accuracy, precision, and linearity, the appropriate solutions were selected to check these absorbance tests. For these absorbance tests, we're using 3 concentrations of potassium dichromate in perchloric acid. These NIST standards are known as UV20, UV60, and UV120. They are all references for the 200 to 400 nanometer wavelength range. Now, these UV20, UV60, and UV120 were all measured 6 times, and the means and the standard deviation were computed at each of the 4 wavelengths. Each absorbance spectrum crosses the dashed line at the 4 different wavelengths exactly right. To visually show how narrow those tolerances are, each spectrum must be accurate to less than the thickness of the green line in the bottom right. The accuracy here was well within the set limits. For absorbance precision, all of the 6 replicates are shown. They need to be within the green arrow bars at each wavelength. And as you can see, they're right on top of each other, well within the limits. For photometric linearity, a linear regression of the means of the 6 replicate measurements at each tested wavelength of UV20, UV60, and UV120 is plotted through 0. The calculated R-squared value is well within the spec of being higher or equal as 0.999. Now, stepping away from absorbance, wavelength accuracy can be determined by measuring the absorbance spectrum of traceable certified reference material with well-defined peaks at multiple wavelengths and comparing the measured to the known peak maxima. Holmium oxide in perchloric acid is an internationally accepted liquid intrinsic wavelength standard, identified in both United States and European Pharmacopeia. The acceptance limits of the measured peak maxima are calculated by adding the measured uncertainty to the acceptance criteria. All measurements are well within the criteria, as the largest error between expected and measured is actually only 0.7 nanometers. Spectral resolution refers to the ability of a UV-Vis spectrometer to resolve features in an absorbance spectrum. The spectral resolution of Lunatic is better than 2 nanometers. Thus, if an absorbance minimum and maximum are at least 2 nanometers apart, Lunatic can resolve the features. The spectral resolution test is performed by measuring the absorbance spectrum of toluene and hexane and calculating the ratio between the absorbance maximum at about 269 nanometers and an absorbance minimum at 266 nanometers. The acceptance criteria for this test is a ratio of at least 1.3. And as said, the resolution test is performed by determining that ratio. And here we can see Lunatic showing a higher resolution with a ratio of 1.32. And as a final pharmacopoeia test, stray light is any light measured by a UV-Vis detector that is not of the identified wavelength. Stray light that tends to have the biggest influence in the UV range, which is also the most important range for nucleic acid and protein quantification. Lunatic maximizes linearity by minimizing the influence of common sources of stray light, like internal reflections and second-order diffraction. Acetone is used since it absorbs almost all light below 320 nanometers. So if any light is detected, then it's known to be stray light. And here you can see that absorbance remains above 3 for the whole range below 320 nanometers. But specifically at the 3 wavelengths of 260, 280, and 300 nanometers. This means that any stray light in this region is less than 0.1% of the signal. The UV-Vis performance verification kit and software makes testing Lunatic for pharmacopoeia compliance a snap. The kit contains the 8 sealed cuvettes with the certified reference materials we just discussed to satisfy all the USP and European Pharmacopeia verification tests. These cuvettes are placed in a one-of-a-kind metal frame so they can be read by the instrument. Lunatic software advises the user on which cuvettes to use for each test and analyzes the results automatically, giving a simple pass-fail check at the end. It will maintain an audit history of when each test was done, whether the instrument passed, and reports detailed results for review after each test, all to help you easily validate Lunatic for your downstream processes. Now, that was showing the compliance of our spectrometer. Let's see what the results are of reference standards in our consumable with fixed pathlengths. Uracil and tryptophan are two pathlength absorbance standards for microvolume specs, certified by the National Institute of Standards and Technology, or NIST. Uracil and tryptophan NIST standards are measured for absorbance, and the expected value is compared to the measured value. If they are close, then our fixed path length can be used for accurate and reproducible measurements. Now, next to that, a NIST IgG standard was used to prove the overall performance on 2 microliter of sample in high lunatic plates. NIST monoclonal antibody is a representative test molecule for therapeutic protein characterization. The uracil and tryptophan NIST standards were used to show that our fixed path lengths are correct and reproducible. Here you can see the percent bias and can be defined as how far off our measured results are from the certified result. In this graph, we are comparing the measured OD values to the certified values. All of the path lengths calculated based on the 8 measured absorbances in 5 different lunatics of the uracil and tryptophan standards were within 2% of the nominal path length. Mean values shown by the X and median values shown by the middle black line of these 40 measurements were within 1.25% of the reference value. NIST map is a representative test molecule for therapeutic protein characterization. According to the standards defined by the USP, analytical methods for determining drug concentration should be within 2% of the known concentration, plus or minus the manufacturer uncertainty. The NIST map manufacturer uncertainty is about 0.4% of the reference value of 10 mg per mil. So an analytical quantification method should be within 2.4% of the reference concentration. Now here you can see the measurements done in octuplicate with 2 microliter of the NIST map in high lunatic plates on 5 different instruments. All measurements in the 5 tested lunatics were within 1.25% of the 10 mg per mil reference concentration of NIST map, as shown by the whiskers of the box and whisker plot. Mean values shown by the X and median values shown by the middle black line of these 40 measurements were within 1% of the reference value. Now, verifying Vis performance with NIST standards gives a solid snapshot of instrument operation, but it only covers a few absorbance metrics. The fundamentals is a third-party certified kit containing 5 tryptophan standards in a dynamic range from 20 to 225 OD. The fundamentals make it easy to prove accuracy, precision, and linearity in the wavelengths most relevant for proteins with 5 concentrations of aqueous L-tryptophan. Since tryptophan residues cause most of protein's absorbance at 280 nanometers, the fundamentals is an appropriate model for most protein applications. And to make it all a piece of cake to test your system with these standards, Unchained Labs offers a specific fundamentals application on Lunatic. Color coding shows where you need to load each standard and allows you to fill in the target concentration and uncertainty. So all calculations are done with our software. The fundamentals application will give you easy to read results per standard and an overall linearity for the full series. The average concentration, the mean recovery, and relative standard deviation versus the target concentration were calculated by our analysis software for each of these standards. Plotting the average result of each standard shows the great linearity of Lunatic over a dynamic range of 20 to 225 OD. Overall, the average concentration was within 1% of the target concentration of every single standard. All percent coefficient of variation were less than 1%, even at the highest concentration, showcasing Lunatic's high degree of precision. All this so you can easily check the instrument as much as you want. And next to all these standards, this also works for real samples. Because of our huge dynamic range, you can run any protein without ever having to dilute again, and get spot-on precision within 1% CV and accuracy within 2%, and crazy linearity. And that can all be seen on this IgG dilution series. Also, don't lose sleep over instrument to instrument or lab to lab variation. Lunatic loves repeating itself, so standardizing your methods across all labs is very easy. With boatloads of samples at multiple locations, the last thing you need is to struggle with validating the same workflow over and over again. Here you can see a box and whisker plot with 3 concentrations of DNA. Either run in octuplicate on the same system or run in octuplicate on 8 different Lunatic systems for a total of 64 samples per concentration. On one instrument, we've already discussed the amazing results earlier in this presentation. But here we can also see that with 8 completely different systems, there's also nothing to worry about. Having systems in different labs in the same building or even at different sites globally will always provide the same high quality results. Now, next to Vis performance verification tools, we also offer optional 21 CFR Part 11 software tools. This will get your data and experiment integrity, provide a full audit trail, and lets you do electronic signatures. Unchained Labs also offers IQOQ and IQOQ performance verification services for Lunatic systems. And in addition to these amazing capabilities we've discussed so far, Lunatic also meets the needs of labs working in larger scales. For these high throughput needs, the plates used for Lunatic are fully compatible with liquid handling robots. So Lunatic is the perfect system to unify biologics quantification across an entire workflow, from research to quality assurance and quality control. The high performance Vis spectrometers of Lunatic makes quantifying protein or nucleic acids easy. And their software features a range of applications that gives valuable quality and purity information on samples. Accuracy and precision you can prove for yourself in full compliance with both the US and the European Pharmacopoeia standards, giving you the best results from Lunatic for any environment. So if the old ways of doing quant are a rowboat, all those options make Lunatic a jet ski. It is fast, agile, and with minimal labor, it will get you to your destination. And you'll have fun working with it as well. Thank you for attending my presentation. I'll take any questions now.
That was good. Thank you so much, Nellis. I really like that jet ski picture, by the way. That was great. Excellent. So good. So before we get to the Q&A, I just want to recap really quickly. I took some notes to make sure that I get everything that you had there. So high throughput, right? 96 samples per plate. Low volume at 2 microliter. And the plate is really special, right? Because essentially it's an SBS plate format. And from what you've said to us, it is fully compliant and compatible with any of the requirements for performance downstream. But more importantly, if someone needs to automate their system, then certainly the Lunatic and its sample holder can be moved downstream pretty easily. And then you also went on to talk about performance, right, versus compliance requirements. And so when we think about moving tools downstream, right, so compliance-wise and performance-wise, we have really high standards that are required. So you mentioned the pharmacopoeia, the fundamental kits. I think I also saw the 21 CFR Part 11 and the IQOQ that can be done for that system. So it's quite a complete suite of options here available for someone to be able to move it downstream. What I really like about what you said and this platform is the fact that I think for the first time, right, we're allowing users to essentially speak the same language upstream as they do downstream, meaning that if they move that system downstream and there's a deviation in the performance of their product, they can rest assured that they can talk to their colleagues upstream without having to think that maybe it's a different system or a different reader that actually gave them that deviation. It is in fact maybe something in the process that may have gone wrong. And then finally, I think you said to us that the accuracy is at 2% or better, precision is 1% or better. So really just fantastic tool. So I hope I've captured everything, but I was just trying to take some notes to make sure that I get the gist of what you were saying. Excellent. So to the audience, I'd like to welcome you to join us in the Q&A. We have some questions there. I'm going to begin from the top one. The first one is, can the pharmacopoeia test be done by the user? So can I do the pharmacopoeia test myself is the first question.
Yes, so next to the services we offer, it is also possible to purchase the cuvettes from third party because they're third party certified. And then you can run them as many times as you want within the software.
Sounds good. Thank you very much. The next question is LIMS integration possible?
Yes. There are multiple types of reports possible from our software. You can also completely customize that and so decide what is best for your LIMS integration afterwards and make everything automatic that way. So that's also no problem at all.
And as a follow-up to that question, like what kind of format can I use for my exploit reports?
I'll try to remember them all. So we have the standard CSV and text formats, but also PDF, standard Excel. So XLSX and HTML are possible.
Excellent. So lots of options there. Thank you. Let's see. So someone said, does a Lunatic use barcodes on its plates so we can track and link samples?
Yes. So our plates are all barcoded. You can use it in your liquid handling robot, for example, to track it and have your plate and your source plate all linked within our software. So that is all possible as well.
And can you comment on the actual barcode itself? Like, where's the barcode reader?
There's a barcode reader inside the system, so you can have your template set up for an experiment file be barcode specific, and so then the instrument will check if it has the correct plate inside to avoid any someone putting in the wrong plate, for example. Then the instrument won't read it until it has the correct barcode.
Okay, sounds good. So there are some questions submitted as well ahead of this. One of the questions is, can you discuss the fundamental kits and how it works?
So it's quite simple. It's a third-party certified standard. It has 5 different concentrations, and so we just measure it as you would do with any other measurement. The only thing next to that is we have a more detailed app that does all the calculations for you, and basically on your vials itself that you purchased, it will have a target concentration and an uncertainty of that value coming from that third-party certified. And so the software will check everything going from mean recovery to standard deviation. And then across all 5 standards, it will check linearity for the system.
Excellent, thank you. And someone's asking, are different user access rights possible?
Yes, so within the software, we have 4 different users possible, going from highest level administrator, supervisor, a general user, and an operator. All have their specific rights to perform. And so depending on the lab, you can choose who has which rights to keep everything within what are your requirements.
Okay. Sounds good. Excellent. Thank you very much. Let's see. So someone said, does the Lunatic provide contamination reports at specific wavelength? So at an ideal wavelength, for instance, DNA, so on and so forth. So I'm assuming they're referencing the unmixed apps and the ability to deconvolute your main target molecule versus other contaminants.
Yeah, so depending on the app you choose, it is possible within that app that the system will look for certain impurities. And so then it will also report information on that impurities if they go above a certain threshold. So if you have enough of one impurity, the instrument will report what it is and what potentially the concentration is.
Excellent. Thank you very much. Good. So I think there's a question here that goes, is there a test that reports on A260? So I'm assuming they mean an application that measures A260 absorbance. Can you speak on the different options, please?
Yeah, we have multiple applications for DNA and RNA as well that can go from basic UV-Vis measurements, as you would do on any classic system, or the more detailed mix applications that will look for certain impurities. Specific then for nucleic acids, it would all be reported at A260.
Sounds good. Thank you. I guess someone is asking whether or not they can purchase the UV-Vis performance kit themselves, or will they have to get it from a third party, and can they even run it themselves?
Yeah, so the only thing that is purchased from Unchained Labs directly would be the special plate to hold those sealed off cuvettes that was shown in the pictures. The cuvettes itself need to be purchased from the third party, and everything like recalibration and all of those certified cuvettes would all be handled through that third party. If you don't want to deal with all that administrative stuff, we also provide all those services where then an engineer would come by with Unchained Labs cuvettes and do all the measurements for you.
Makes sense. That's probably a good idea, right? Just have someone who knows what to do, handle it. Just leave it to the pros. Good. Next question for you is, do you have examples of customers who essentially have actually successfully moved the Lunatic downstream? And I don't know if you can name them, but maybe context in which that's happened.
Yeah, I won't name any of them, of course, but yeah, we've seen people that started with an instrument upstream just in their research and liked it in the R&D group and just looked at the options to go downstream. And there are multiple cases where that happened. Indeed, just because that was the issue, like I said in the very beginning, there are only very limited systems that can pass the tough criteria for these systems, as we just went over all the tests. But those are just rather slow, while we can do 96 samples in 10 minutes. So having something to move downstream to manufacturing and quality control like Lunatic is definitely, yeah, has definitely been done and is definitely good.
Sounds good. Another question submitted had to do with the sample holder, the actual plate itself. So I'm assuming, based on their question, that they're asking about evaporation and cross-contamination. So maybe can you comment on the actual plate design and how that would essentially prevent you from having some carryover from past runs?
Yeah, so it's specifically designed for that 2 microliter. As you saw in the presentation, there's a small input well, but then the sample completely would go in our capillary. And so there's very limited access to the outside world. And so there's no noticeable evaporation at all, which will influence reproducibility within 2 hours after loading. So that allows you to already have your plate filled. And if someone else is using the system, and 10 minutes later, his plate would be done and you can put in your plate. Now, contamination, there's a vent hole where the pump will apply pressure, negative pressure on it. It will aspirate the sample into the cuvettes, but then there's still a fluidic stop and a reservoir to avoid any risk of having the sample eventually get into the system. So the full sample stays in the plate and there's no risk of cross-contamination or anything like that. You just, after you've used the plate, you throw it away and that's it. You don't need to clean the instrument or anything afterwards.
Okay. So really it's a single-use plate as well, right? I think single-use cuvette at least. So you really cannot cross-contaminate by using or introducing a new sample to the exact same cuvette afterwards, is what you're saying.
Yeah, exactly. We also get the absorbance of the plastic before we actually read the sample. So we need that empty cuvette to be read first to really see, to really eliminate that absorbance contribution from plastic as well for that specific position. So everything to optimize our results.
Sounds good. Excellent. And someone's asking an interesting question here. Can the Lunatic quantify any other material type other than whole blood? So I guess maybe can you speak on the different molecule types that we can handle, including perhaps extracted samples from blood, I guess, as a sample type?
Yeah, so pretty much everything can be, as long as it absorbs in the UV-Vis range, we can run until, well, I would say until certain levels. If it's 100% sugar and you can't pipette it, then we won't be able to measure it either. But otherwise, any nucleic acids, we have specific oligo applications, we have specific DNA and RNA applications. All the calculations will happen automatically as well. So you don't need to do anything yourself. You'll just get a concentration and you can move forward with that. Similar for protein, we have different protein applications where you just put in your E1% specific for your protein and all the rest will happen automatically again. What else do we have? We have applications for labeled samples. So if you have a dye, well, your nucleic acid or your protein is labeled and it has a dye, then you can use that as well. You can specify which dye at which wavelength it absorbs and all, and again, all the concentrations and the degree of labeling and all can be automatically calculated. And I would say finally, applications like, the more old school things like a standard curve or even colorimetric assays can be run on our system. So pretty much anything that absorbs.
I think it's funny when you said it, I was chuckling, right? Because there are over 50 applications on the platform. And so there's, we can handle just about most molecule types. So that's good to hear. Excellent. I think these are all the questions that were submitted. And so thanks all of you for joining us today. If you have any more questions or if you'd like to hear more about Lunatic, please, contact us at info@unchainedlabs.com or contact your local rep or FAS. We'll be happy to have a specific discussion with you about your specific needs and how we can provide you with the right solutions. Once again, thank you, Niels, for the presentation today. This was really enjoyable. I'm always excited about new developments and other ways to use the tools that we have. And I think being able to move that instrument downstream, that's the hallmark of a high-performing system. And I think that's always good to hear. And so thanks again for introducing this to us. Thanks for everyone for joining us. Have a wonderful day, and we'll be in touch soon. Take care.
Bye.